Okay, for today's lecture, we are going to discuss the conservation of linear momentum for system of particles. So last time we have discussed the principle of linear impulse and momentum, and today, based on that equation, okay, the principle of linear impulse and momentum states that the initial momentum of the particle plus the sum of the external impulses will result to the final momentum of the system. Now, if the external impulse is zero or negligible, so what will happen is that the initial momentum of the system is equal to the final momentum of the system. So that is what we call the conservation of linear momentum. So in equation form, it is stated that summation of the mass, initial mass, and the velocity should be equal to the mass times the final velocity. So this is called the conservation of linear momentum. Now, when will you apply this equation? First, if the sum of the external impulses is equal to zero, meaning the forces it cancels out each other. Or there are times we need to distinguish between impulsive force and non-impulsive force. So what are impulsive forces? So based on the definition, impulsive forces occur due to an explosion or striking of one body against another. So, no, pag strike nimo sa isa ka body, na-change ang iya ang direction sa iyang velocity or momentum niya. So, meaning you exert a large amount of force at a short time interval. Okay? So, in contrast, what are non-impulsive forces? So example aning non-impulsive forces is a weight of the body. Okay? So ang weight sa body can be considered as non-impulsive, meaning it does not cause too much change of the direction of the body for a short time interval, no? Pero kung taas na kay nga time interval imong i-consider, so dili na siya mahimong non-impulsive forces. Another example of non-impulsive force is a spring with very small stiffness, no? Kanang spring bang luyat bitaw kay dili bitaw gamay bitaw kay stiffness. So kana wala pa na ma-impact na dako nga impulse or change of momentum sa imong particles. Okay, so kaning pag-strike nimo sa tennis ball, this is can be considered as uh, impulsive force. Why? Because okay, so pag travel sa imong bola na, you hit it with the racket, ma-change ang ang momentum or direction niya. So meaning you impart large forces. Okay, so how do you analyze using conservation of linear momentum? Usually, ginagamit na siya in order to determine the final velocities of the particles just after the time period considered. Okay? So, usually, it is applied sa aning when two bodies collide, no, with each other. Okay? So, muna usual niya kung ano. And then, naatay what we call the internal impulses. Ang internal impulse naman will always cancel out each other. So, they occur in equal but opposite collinear pairs. So, ang internal impulse, wala dyan na siya ma-cause nga change sa momentum sa system. Internal, no? I'm referring to internal forces. Okay? So also you need to establish the coordinate system and then draw free body diagram for each particle of the system in order to identify the internal and external forces. The conservation of linear momentum applies to the system in a direction which either has no external forces or the forces can be considered non-impulsive. So again, mo ni ang iyang requirements, no? There are no external forces or ang force nimo can be considered as non-impulsive. And then establish the direction and sense of the particle's initial and final velocities. Now, if you do not know kung padulong ang imo ang object, assume it is along the positive inertial coordinate axis. No? Okay, so let's have an example. So you have this car. The 15 megagram boxcar A is coasting at 1.5 meter per second. So this is car A going to the right. Now, it encounters a 12 megagram tank car B coasting at 0.75 meters per second toward it. If the cars collide and couple together, determine the speed of both cars just after the coupling. And also, determine the average force between them if the coupling takes place in 0.8 seconds. Okay, so let's have this example. Okay, so in this example, you have car A traveling to the right at a speed of 1.5 meter per second and tank car B travels to the left with 0.75 meters per second. Okay, what you are asked is to find the velocity when they couple together. So, natabuan is you have car A and car B nagdikit ni sila, no? Okay? Okay, nagdikit sila, no? They couple together. So we will assume that after nila pag-couple, nag-travel sila duha going to the right with the velocity v2. Okay? So, or not v2, but uh, okay, v2. Okay? Velocity v2. Okay, so the question is what is v sub 2? So, ang tanaw na to, no? Ila ang free body diagram. Car A pushes car B. No, exert na during aning state. So, nag-iduot niya ang B. Ang B also, reaction niya, iya pong iduot ang A. You have negative F. So what happens is kaning nga forces, kaning duha nga forces occur equal and opposite each other. So these are internal forces. Internal forces, no, kay nagdikit man sila duha. Okay, so meaning ana sila weight ang A o B pero again that is non-impulsive forces. So mahitabo is there is ang forces nila cancels out each other, so you can apply the conservation of linear momentum along horizontal. So you have summation of MIVI is equal to summation of MI MI V2. Okay. Okay, so you have mass of A is Ang masa A is 15,000 kilogram. Okay? So you have, saan may taban? You have MABA1 plus MVBV1 is equal to MA plus MBV2. Okay? Okay. So sa may taban, you have 15,000 times 1.5. Kani, going to the left, so may minus. Ang mass sa B is 12,000. 0.75 is equal to 15,000 plus 12,000, 27,000 V2. Therefore, V2 is 0.5 meter per second going to the right. Okay? Okay, so that is for letter A. For letter B, we are asked to find the average force. Kung saan sa pagkuha, we need to consider unsa dani ang F, unsa man mo ni pangayo unsa ning F. So we need to consider one of these two cars. Pwede car A, pwede car B. So for car A, unsa may na-experience niya, no? Okay, kung travel siya og dito, ang na-experience niya is kaning negative F, no? Naigatulod sa iya nga force negative F. Will now apply para makuha nato ning kaning F kani. Buta na nato ning F average kay mo may pangayo. We need to apply the principle of linear impulsive momentum. So you have MA VE1 plus integral of F dt is equal to MA V2. Okay? Keep going to the right. So you have 15,000. VA1 is 1.5. Again, kani going to the left man, so may mo running F average times constant man eh. Pwede na magpagawas. Ang time ng game there is 0.08 seconds. 0.8. It's just equal to 15,000 times V2 0.5. Okay? Kung sa'yo mabilin you have the F na lang. F average is just equal to 18.8 kilonewtons. Okay? So that's it. There are just practice solving these problems.